All right, you are welcome to today's class, JAMB class. Today we'll be looking at top 10 questions that would likely come out in your JAMB this year. Top 10 questions that you will likely see in your JAMB this year. And these questions are basically from the organic aspect of chemistry. The organic aspect of what? Chemistry. That is organic chemistry. Now, let's start to answer the question one after the other. Now, we have one, the catalytic hydrogenation of alkenes produce dash. Now, let's take note of something. We have catalyst, we have hydrogenation, and we have alkenes. Now, we are looking at hydrogenation of alkenes, but this reaction takes place under the catalyst. That is, you know what catalyst does in a reaction is to alter the rate of a chemical reaction. Now, our major concern is hydrogenation of alkenes. Catalyst is just trying to tell us that the reaction occurs under the catalyst. Now, what is hydrogenation and what is alkenes? When we talk about hydrogenation, let's answer it here. Hydrogenation means addition of hydrogen. Alkenes, of course, you know alkenes is the one that has that double bond, right? Now, for us to be able to answer this question properly, we are adding hydrogen to what? To alkenes. Hydrogenation of alkenes. Adding of hydrogen to alkenes. Now, for us to be able to answer this very well, let's bring out one members of alkenes and then add hydrogen to it. So, we will be able to determine the one we will arrive at in that four options given. Let's pick one particular example here. Ethyne. So Ethyne has a formula of C2H4. So let's add hydrogen to it now. Hydrogenation of Ethyne, because this Ethyne is under alkenes. It's a member of alkenes. So let's add hydrogen to it. When you add hydrogen to Ethyne, this gives us, now we have C2 here, which is carbon. The carbon is C2. And the hydrogen now, we have 4 hydrogen plus 2 hydrogen. That is what? 6. That is H6. C2H6. This C2H6, it is under which member? And first of all, what is the name? The name of this is called Ethyne. It is called Ethyne. Why? Why is it Ethyne? And how did I know that it is Ethyne? Now, and before you determine that, Ethyne is under what? It's under alkenes. Ethyne is under what? Alkenes. Why? Let's bring out the formula of alkane for us to determine properly. So the formula of alkane says CnH2n plus 2. I would like to tell you that I have a separate video on how you can easily know the formula of alkenes, alkynes, cycloalkenes, and cycloalkenes. I will drop the video in the comments, and I will drop the video in the description. Please do well to check my descriptions, or you can check more other videos on chemistry that I have on my channel. Okay, so this is the formula of alkenes. I said this is under alkenes, so let's try that. Suppose our N, this is represent our A now, so this will be Cn, which is N is equals to 2 here. C2H, this N is equals to 2. 2 times 2, that is what? 4. Plus 2, that is what? 6. You can see that it match this formula, which is under our what? Under alkene. And it is called what? Ethyne. So this tells us that hydrogenation of alkenes give us what? It gives us what? Alkenes, not alkynes. It gives us what? Alkenes. Please take note of that. Take note of that. But what if in an examination condition, what if you now see the hydrogenation of alkenes? That is, when you remove hydrogen from alkenes, it will give you what? Alkenes. It's to give you what? Alkenes. But something can likely happen along the way. If you look at the option, if you look at the question number 2 now, something could likely happen here in this question number 2. So hydrogenation of alkenes, let's done with this number 1. hydrogenation of alkenes give us what? Alkenes. So the correct answer to question number 1 is option B. So let's look at question number 2. But this question number 2 now, something happened. Hydrogenation of ethyne yield dash. Now, question number 2 says uncontrolled. Question number 2 says uncontrolled hydrogenation of ethyne yield dash. Please, this statement is very important. Uncontrolled here is very, very important. You know, when you talk about hydrogenations, they usually occur under the catalyst. Maybe the catalyst is so designed is such that, you know, when you hydrogenate ethyne, it must stop in some certain points, but the catalyst does not stop. It continued with the hydrogenations. When the hydrogenation got to a level that it's no longer controllable, the product will be different. But mind you, if they don't tell you this in a question, I will explain that. Let's look at that first. Let's look at this. Now, ethyne, we are hydrogenating ethyne. We are hydrogenating this ethyne. What is the formula of ethyne? Ethyne says what? Ethyne says C2H, C2H2, C2H2. This is the formula of ethyne. Now, the question says hydrogenation of ethyne. Now, you know what hydrogenation means? Adding of hydrogen plus hydrogen. You know, when you add hydrogen to this ethyne to give us C2H, I will then explain what that uncontrolled means there. It will give us C2H, H2, we have H2 here, we have H2 here, that will give us H4. This reaction is supposed to stop here. When you remember our explanation earlier in that first question, the reaction is supposed to stop here, but the catalyst does not agree. It continues the reaction. So instead of the reaction to stop here, it will continue to be hydrogenating. So that is another hydrogen will now add to this again. When another hydrogen now added to this, when another hydrogen adds to this, it will give us what? C2H what? 4 plus 2, that will be what? 6. It gives us C2H6. This tells us that now at this point now, we have reached a member in under alkane. When you get to alkane, you can't hydrogenate again. That's where you stop. Now it has, instead of this thing to stop at ethyne here, because this is the formula of this is the formula of ethyne, this is the formula of ethene. Why this is the formula of ethane? Can you see the difference? Ethyne, that is this is the formula, ethyne. This is the formula of ethene. Why this is the formula of ethane? Now, when you hydrogenate ethyne, what it's supposed to give us is ethene. But because we're told that it's uncontrollable, it keeps hydrogenating till it gets to what? Ethane. So uncontrollable hydrogenation of ethyne will give you what? Ethane. And the correct option there is option A. But maybe uncontrolled is not mentioned. If they ask you hydrogenation of ethyne, it will give you what? Ethene. Please take note of that. But because uncontrolled is being mentioned here, it will hydrogenate till it gets to alkane. You know, alkane, they are not reactive again because they are completed already. So when it gets to alkane, it will then stop. So uncontrolled hydrogenation of ethyne will give us what? Ethane. Ethane. This is the formula of ethane. I explained that in question number 1. Okay, let's go to question number 3. For question number 3, the type of reaction that takes place between propane and halogen is Now, propane as is a member of alkene. Take note of something I want to write. We have alkane, we have alkenes, alkenes, alkynes, and benzene. You know, as we have alkanes, we also have cyclo form of alkanes. As we have alkenes, we also have cyclo form of alkanes. Now, the thing is that alkanes has single bond. Alkane has single bond. Alkenes has double bond. Alkynes has triple bond. And benzene, you see, saturated compound. When you talk about saturated compound, we are talking about compound that has single bond, and that is alkane. But when the bond is like 2 or 3, it is called unsaturated, which is alkyne, alkenes, and benzene. Now, in these reactions, you know, since this is substitution, like what's it called? Since this is saturated compound, they undergo substitution reaction. Take note of that. Saturated compound undergoes substitution reaction. You know what it means to substitute? One we have to go out, one we have to come in. Okay? They undergo substitution. We have what we call substitutions, addition, and addition reactions. Alkane, because it has single bond, it undergoes substitution reaction. It is only compound that has single bond that undergoes substitution reaction. But I will tell you that one thing happened there along the way. Alkynes and alkenes, they have multiple bonds, like 2 or 3 bonds. So they undergo addition reaction. These two undergo addition reaction. But you see benzene undergo both addition reaction and substitution reaction. Benzene is different. This one only undergoes substitution reaction. So the cycloform of alkane too is also single bond. So cycloalkanes will also undergo substitution reaction. Cycloalkenes, because alkenes undergo addition reaction. So cycloalkenes will also undergo addition reaction. So but benzene undergo both addition and substitution reaction. Why? And usually benzene, take note of this, benzene prefers substitution reaction rather than addition reaction. The reason is that addition reaction usually spoil, damage the benzene ring, but substitution reaction does not. So because of that, benzene prefer to undergo substitution reaction rather than addition reaction. Take note of that. If you have any questions, please drop it in the comments. Okay, so the reaction type that takes place between propene now is under alkenes and halogen. So it is what is addition reaction, because alkenes undergoes addition reaction. It does not undergo substitution reaction. Take note, it undergo addition reaction. So the correct answer to question number 3 is option B. Option B. Now look at question number 4. In fact, if you listen to my explanation earlier, I've already mentioned that. They said, the question says ethane and benzene undergo both, they can both undergo dash. Now, ethane is alkane. Benzene, now we have ethane under this alkane and we have benzene. I said something. I said benzene undergo 2 reactions, addition reaction and substitution reaction. So it undergo both addition and substitution reaction. Why this one? Alkenes, they undergo what? Substitution reaction. So both ethane now, which is under alkenes, and benzene, what is common? They can both undergo what? Substitution reaction. Substitution reaction. And I also told you that benzene prefers substitution reaction because substitution reaction does not spoil the benzene ring. So the correct answer to that is option B. Both of them undergo substitution reaction. Take note of that. Now, number 5 says the reaction between alkanes and halogen is alkanes is this. It undergo what reaction? I've already mentioned it here that it's what? Substitution reaction. Substitution what? Reaction. It does not undergo this. So it is substitution reaction. And number 6, petroleum fraction products. Petroleum fractions produce ethene by, it is by cracking. You know, when you separate your crude oil at the refinery, majorly we have the oil and the gas part. So when you separate, you only get majorly the alkane products like methane, ethene, like that, propane, butane. But you see, this, when you see ethene cannot be gotten directly like that. You get this ethene by cracking the alkane products you have. You know what it means to crack? We can get ethene by cracking, not reforming. But what do we get? I want to give you a task to do here. Reforming is used to get that. Which product do we use reforming? Like the way you use cracking to get ethene, you use reforming to get what? I've mentioned, like, I have not mentioned it actually, but you can make research. Very simple. I've already mentioned that name before. You use reforming to get that. I want to give you these 3 options. A alkyne. A alkyne. When I mean by alkyne, it could be Ethyne. B benzene. C phenol. D styrene. Drop your answer in the comments. Okay? Now, the correct answer to this is cracking. This is where you crack those what's it called? Those Alkenes products you got, that you'll be able to get the Alkenes product, which is ethene, e.g. Okay, for question number 7 now says, which of the following is unsaturated? I explained something earlier that when we have alkane undergo on alkane, here is only saturated compound we have. So the rest, they are unsaturated because they have 2 or more bonds. Even if we check benzene structure, you will see that benzene at times have double bond. Okay, so this is unsaturated, unsaturated, unsaturated. The only one that is saturated is alkane. I also told you that since alkane is saturated, also the cycloform of alkanes will also be saturated, like cycloalkane. It also be saturated. So they are just trying to twist the question, like, and the option given to you. They want to test your brain. They want to test you whether you actually understand what it means to be, what saturated and unsaturated compound means. Okay, so don't be confused. Okay, it's very simple. It's very simple. So which of the following is unsaturated? You know, ethane is under alkane, is saturated. Benzene is not saturated. I've already mentioned it. You don't need to stress yourself. But look at this now. 2-methyl-pentane. Don't be confused about this. These are just a substituent, but the parent name is pentane, and pentane is under alkane, which tells you that it is saturated. And these two, cycloalkane, is just a cycloform of this. This one too, cyclohexane, is a cycloform of alkane, which is hexane. The cycloform of hexane, which is called cyclohexane, is under alkane. So it is still saturated because it is under this what alkane. The only one that is unsaturated here, it is called benzene. Please take note of that. Take note of that. So I'm going to erase this and write the remaining 3 questions that you will likely come across in your JAMB this year. So let's look at the remaining 3 questions out of the 10. Now, let's look at the remaining 3. Number 8 says the main constituents of petrol are the main constituent of petrol. What is the main constituent of petrol? First of all, what is the formula of petrol? The formula of petrol is CH18. CH18. So it mainly consists of carbons, that is 8 carbons and 18 hydrogens. But it consists of carbons and hydrogen, which is what? Hydrocarbons. Hydrocarbons. This question is just to test you whether you understand what you are reading or not. So you don't need to start to bother yourself about alkanols, alkanoic acid polymers. It's telling you that what are those two things that contribute together to form a petrol. What are those things you can see inside petrol? Like, what are the components? Let me put it like that. What are the components of petrol? That is what the question is trying to ask you. So it contains only carbons and hydrogen, that is hydrocarbons. The correct answer to that is option B. Take note of that. It's option B. Okay? And for number 9 now, says, why is carbon often deposited in the exhaust pipe of a car? First of all, let me explain something to you. Have you ever observed that if you try to burn firewood, as an example, if you set fire on firewood, do you notice that if the fire does not burn very well, or it does not burn very well, you will start to see what? Or let's assume you pack clothes outside that maybe they are little somehow wet, and you set fire on it and it doesn't burn very well. You start seeing something like smokes coming out. This smokes is as a result that the properties or the fire or the clothes does not burn very well. But if it's burning very well, or the firewood is burning very well, you notice that you don't see any smoke. Have you ever observed that? So likewise it is in petrol here. If petrol burn completely, you will not see smoke. But if you see anything smoke, it's as a result that petrol does not burn completely. And if petrol does not burn completely, there is presence of a carbon that is a carbon compound, which is a CO, carbon 2 oxide. At times you also call it carbon monoxide. So there is presence of CO, which are very dangerous. So what results to that? What results to those carbon to be coming out is as a result that petrol does not burn what completely. So that was for you to understand this. That is why I made use of that was why I made use of properties like clothes. If they don't burn completely, you start seeing smoke. But if they burn completely, you don't see smoke. And we use another word, firewood, which we know that we are somehow familiar with. So what causes that is because it is incomplete combustion of what? Petrol. Option B is the correct answer to that. And for question number 10, the polymerization product of ethyne is, now when you polymerize ethyne, what is the meaning of polymerization? Is it not when monomers come together, okay, to form a larger, one? So that is polymerization, when monomers come together. So when monomers of ethyne come together, they will form what we refer to as benzene. But the funny thing is that can you be able to identify benzene among the following option that is being given? Benzene, the correct answer to that is this is the structure of benzene. And another way you can write benzene in this form is you can also see it like this. What matters in how you put your bond is that when you put one, I can decide to start here. It does not necessarily mean I will have to start here. But the rules is that when you put it on the first one, don't put it on the second one. Put it on the third one. Don't put it on the next one. Put it here. Why? For your question, why is it that we don't put it here again and put it here again? Because of what? Because if you put it here and you put carbon here, carbon can only accommodate 4 bonds maximum. So when you put one carbon here, it says that there is another hydrogen that is being joined to it, one hydrogen, because benzene has C6H6. So when we have each of these angles tells us that it is carbon that are present in those angles, and one hydrogen join. So if I put it here again and carbon here and I join it with another hydrogen, you will see that the bond will be more than 4. 1, 2, 3, 4, 5. It's more than 4. So that is why we don't do it like that. Okay, take note of that. That is the reason why we don't put the double bonds in all of them. So when you put it, if it starts from here, when you put it here, leave this one. Put it here, leave this one. Put it here. That is just. And another way you can see benzene is this. You can see it in this form. It is still benzene. Yes, you can also see it in this form. It is still benzene. Why this one is called what? This is called you can call this one, you can call it cyclohexane. You can call it cyclohexane. All right, if you find this video, I know of course you find it very helpful. Don't leave this channel without liking the video. Please like it and recommend the video to your friends, and do well to subscribe as well. Thank you very much for watching. See you in my next video. I wish you success in your exam.